Hello everyone. We are the World Innovators from VIIT Pune. Myself Adita Pawar and along with teammate Jay Patil. Today we will be presenting our case study on the electric scooter company's product and app issues. Over the course of this presentation, we will walk you through the solutions we have crafted using key frameworks, data analysis, and system design principles to improve the user experience and operational efficiency of the company's product and applications. Okay, as mentioned, we are eVolt Innovators. In this presentation, we will tackle key questions to improve the electric scooter app and product. Our focus is on enhancing the user experience, cloud computing, cloud data integration, intelligent recommendations, and operational efficiency. Now let's dive in. Let's see about the app features, mind map, and top 5 features. To begin, we looked at top 10 features the app should offer for better usability and performance. Some of the key features include real-time battery stats, navigation, integration with Google Maps, a charging station locator, and smart notification. From these 10, we choose 5 features that we believe are critical to enhancing the app's user experience and resolving key customer complaints. Okay, first, real-time battery stats will provide immediate insights into battery life, solving the issue of unexpected power loss. Next, integrating navigation will make ride more convenient. While the charging station locator will reduce range anxiety, smart notification can address delays in alerts, and ride analytics will increase transparency and help build users' trust. Now let's talk about the design consideration for storage for features. Moving on our design consideration, we focused on making document storage seamless and secure. For this, we ensured that the file types like PDF, images, and other documents would be accessible from both the scooter's dashboard and the mobile app. On the security side, we recommend using end-to-end encryption, token-based authentication, and a secure cloud API to store documents safely. Okay, now let's talk about the potential issues and test scenarios. Next, we address two customer complaints. First, charge drops without warning. This could be due to battery miscalibration or faulty sensors. To test this, we simulated issue in the app not showing updated data, which might be due to sync lag or the stale cache. To test this, we simulated data sync under proof network conditions to check for backend to app latency. Okay, now let's talk about the inside out and outside in planning. Moving on to our product release strategy, we employed both the inside out and outside in techniques. Inside out planning involves creating a feature roadmap, setting quality benchmarks, conducting beta testing with employees, and preparing the server infrastructure. Outside in planning is customer focused, where we gathered user feedback, conducted surveys, created user personas, and involved focus groups for UI UX improvements. We believe combining both perspectives is the key to deliver a successful product. Now see features prioritization. Prioritizing features is essential to ensure we focus on most critical one first. We use a relative priority exercise to rank features based on their impact. Features like real-time battery stats, navigation, and smart notification we are ranked highest as they address to the core pain points of users. Lower priority features include voice commands and support service alerts, which can be rolled out in future versions. Okay, further part will be taken by the J. Okay.
Now we come to the issue of data. What issue can data produce? Here we are using cloud computing, so there are issues like latency. Latency is a main issue when trying to fetch data because the internet connections and all are a very huge factor while determining this. Also, API endpoints. API endpoints can sometimes go missing, or the current API endpoint could go corrupted, or maybe you are just not able to access it due to some other issues like packets getting lost or something. Some improvements that can be made here are trying to use the MQTT communication protocol which could help us fetch the data easily. Also, optimizing the database indexes could be a solution for this, which could also help us retrieving the data better. Next, talking about what data is to be collected, how it could help, and what AI could be used here. The data that should be collected are the battery use parameters, the driving behaviors, the temperature, and the charging, which has to be the mandatory things that an EV has to be having. So, the recommendations that it can provide are battery health, optimal charging time, speed recommendations, are some of the things that could be given. So, say we are on road which allows 60, so you should show 60 there, right? So, and when now talking about what AI could be added into here, we could give predictive maintenance, like your battery has to be replaced in a few years or few months. Also, we could give route suggestions using Google Maps or some things like that, and also adaptive speed controls. Like maybe if there's no traffic, then you could increase the speed. If there's a lot of traffic, then you could decrease the speed and stuff like that. Now talking about business and operational matrices. Business matrix could be profit margin per unit, like maybe how much of a profit is getting generated through a single scooter. Maybe we could calculate that by what is the cost that we pay and what's the cost that we get, like the selling cost and buying cost could be the things. Then monthly active users is also good criteria to judge how the business is performing, and this can help us know if people are liking the product or not. Then talking about operational matrices, it could be defect rate, like how many of the scooters are being damaged, or maybe they are working good but they fail after a certain time. Then delivery times are also a thing, like maybe you take 2 months, 3 months for the same, but that's not as ideal for the case that we have been having. Now talking about the past, present, and future of electric vehicles. In the past, we could say that lead-acid batteries, they had a very limited range. There was performance issues with them, like maybe they would drop suddenly or something like that. Then there was a thing of the digital. Like now we are getting digital. Earlier we had analog dashboards like the odometers and all. The present situation uses lithium ion batteries. Lithium ion batteries are rechargeable, they are faster in charging. We could modify the speeds, maybe increase them as per our requirements. Then we could also connect them through apps, like EVs can be tracked through apps, or maybe they could be started, turned off. Now things are being developed. Now talking about the future, we could get solid state batteries, like more efficient. They would be long lasting because there's nothing except the battery. It would charge, discharge. That's all. The other parts will be controlled by the connector or some controller that's added there. And also autonomous driving, which we are trying to make right now. A lot of companies trying, like Tesla is also trying to get into this. Automotive driving is also a very good future for EVs. Now talking about what the dashboard improvement should be made. First of all, the ride history, a few settings, and the document upload thing should be visible on the dashboard. As seen in the images here, that's the kind of dashboard we are trying to go for. Then when we talk about ride history, then not just today's, the previous ones, the month behind or something could be there. The settings is like a common thing, all the EVs are nowadays having it. And the document upload thing, like maybe you have to store your license, ID proofs, or some documents related to your bike or the car that you are owning. That's also a helpful feature. In conclusion, I would like to say that we have had a good analysis of what electric vehicles or scooters and the ecosystem is focusing on. Like maybe we are trying to get the app better, a little bit of battery improvement, then having an app, or maybe storing the documents into the vehicle itself, like that is through the cloud. You could access them easily whenever required. Maybe someone stops you by the road asking for the documents, you could just give them up. Now then we'll focus on the hardware as well as the software part of the EVs, because hardware is also a very good aspect because they have to be durable. So the next step that we should be taking is implementing a few design changes, testing it thoroughly, monitoring a few aspects, like maybe you send them to test through a few people, then you get the feedback from them and then try to improvise whatever happens later. So that will conclude our case study, or maybe you could say a survey that has happened about electric scooters. We believe our recommendations and designs will greatly enhance the experience and operational efficiency of cars. We look forward for a feedback and hope to continue innovating together. Thank you.